live button. Set that to live chat. And there we go. I think that is working. It says we're live on there, so I think that is all up and running. Good, good. I hope you can all hear me. Jimmy, yes, how you doing? How you doing? Hopefully we're coming through loud and clear. Can never tell straight away with this YouTube streaming malarkey. It's a bit different to just recording a video. Good, so if we've got chat coming through, then that means everything's all functional. So what's today's plan? So today's plan, if I jump to this one where we can read it, we want to make a bird node, but I want to run it inside Eve so that I can then use it in my lab environments with other labs so that I can peer to it. Because apart from setting it up just as a baseline so we can keep dropping them in, I also maybe in the future want to set one up to do something like act as a route reflector. Because like for a design I'm working on for work, I'd like to be able to add some route reflectors in and have the data center location peer to the route reflectors, and they could be done using a bird solution. So that's what I'm thinking that we could use it for, but also it could come in handy for stuff like the DN42, because at least DN42 gives you a setup guide for bird that if you registered you could then take and reuse. So I've got a couple of setup guides that I've been looking at, and I've got myself some notes. But the first thing I need to do is build a Linux install inside Eve. So this is where we're going to build our own Debian install to get us up and running. So let's do that first. I should have a build. So we want an empty one, because what we need to do is we need to build it in such a way that we can put the minimum on there, because we don't want to put any config on it, because that's what we want to do later. We want to just set it up and then we can then drop them in and use them. So to start with, I need to put a new folder. So I'm going to jump into FileZilla and I'm going to connect to my Eve node. And I am really going to change keyboard soon, because I am really getting pissed off with these Apple keyboards. So I need to go to folder /opt. I want /opt in here, add-ons, Quem. So what we're going to make is a Linux folder, and obviously we have to name it properly. So under here, I'm going to create a new directory, and I'm going to call it Linux -bird. And that should make it easier for us to find. And then on my desktop, I have a CD-ROM image for Debian. So we'll drop that in there. And we're going to have to rename that to cd-rom.iso. This is just so we can do the install first of the operating system. So maybe I should have done this bit separately, but I thought people might want to see how it's done as well. So there's the CD-ROM the image. So we'll rename that to CD-ROM as per the spec. That should be all we need to do there. Now we're going to connect to our machine and we're going to create a hard disk image. So if I SSH root Eve, and I change into that /bird, okay. And then we're going to create a disk drive. I think 30 gig is probably a bit too big for this. Maybe 20 will probably be fine because we're not putting a desktop environment on there. So if we say that and 20G, so that should create a disk and a CD drive. So if we ls in here, so we've got our blank hard drive and we've got our Linux Debian install. So now I should be able to come on here and go add a node, search Linux, and there should be one called bird. There we go. So we only want one at the time being. We'll call it bird. This is going to be so we're going to basically now set this one up with everything that we want installed on there. And then we're then going to basically freeze it in time so that we can then keep using it for future builds. I'm going to put this with 3 so that the default template should have 3 interfaces. One for management, because sometimes it's easier for me to just SSH into the box virtually rather than using the Eve client. And then obviously we want an uplink interface and a routed interface that we're going to send traffic onto. I think 2 cores and about 4 gig of RAM will be more than enough. So there's our bird box. I also need it to have internet access to be able to install and do all the updates. So I'm going to give it a management cloud. And I'm going to connect that onto the first interface. So the first interface will be management. So we'll rename that so people can see what we're doing. And then once we've built this, I'm then going to drop it into a topology and we'll put 2 of them together and we'll do some BGP between them to make sure that it's working. So now I should now be able to start this node. So we check there, yep, there we go. Did it not boot? cd-rom.iso, we did that, and we created the QCal. And it's not booting. cd-rom.iso, it's there. Okay. Normally that just works. It says booting from ROM. Why is that not working? Let's, where are you? Stop. Look at the destructions again. It tells us to create the hard drive, which is what we did. We don't need to remove it there. It says now we basically connect it to the lab and then we remove it when we're finished. So it should boot from that. CD-ROM, convert ISO. Definitely selected it. Boot failed, could not read CD-ROM. Okay, maybe we'll download the, or if we delete that then, and we will download a fresh image. Maybe there's something wrong with that. Stop. We want Debian. We just want, oh, I know exactly what the problem is. That Debian image I had there was for one that I was testing in VMware Fusion, and that is of course an ARM64 version because I'm on the Mac. So I need to download the correct version. So I just want and install that one. Yes, AMD 64. So I had the I had the ARM 64 version. So what we will do is we will grab that one. Debian ARM. Okay, and we should rename that to cd-rom.iso. So now we have our fake hard drive and our CD-ROMs. Now if we hit start, yay, that's what we want to see. Yeah, that's what I want to do on here. So what I want to do is I want to create this as an image for this and put all of the tools in here. So I think we might as well put iPerf in here as well, just in case we want to do speed tests and stuff like that. So at least then it's got everything that we need. We can bake them in ourselves. And then at least then we have an understanding of how it all works and what's actually been installed into it. So we're going to want to do a graphics install. Yeah, that's the thing. It's like for online and stuff like that, then yeah, I can suppose if you have a pre-built appliance and image, that's good. But it's like here we're building a custom image for use inside this lab environment that you're probably not really going to come across in the in the cloud. But because you kind of like build it once for this environment and then you don't really kind of update it, it's one of those things where it's like you just want it built once and just put everything on there so you can forget about it. So I'm going to choose that one. So it should at least get onto the internet. Yeah, you could do it any way you want, really. We'll just call this bird because when we set them up, we're going to put a number on the end. We don't need a domain. We'll set a root password of testing 123, testing 123, and null zero labs as the user. And again, just the password of testing 123, testing 123. Have you built your node yet? Yeah, so what, the other thing as well, that would be nice is like if I was going to deploy this properly, then obviously we'd probably set up like you probably do, where you probably have an Ansible deployment script, and it just does everything as well for you. Right, so yeah, that would do. And finish. Let's just get the install done. Yeah. Oh, they did have a Q. Oh, yes. Okay, so they did have a QCal version. Oh, good to know for in the future. Because I don't like just downloading these ones. Sometimes I just like to build it myself because then I know what's actually been installed and what's been put in there, you know. It's a little bit of that tinfoil hat moment, isn't it? Do you wish to scan the media? No. That'll be fine. Don't need a proxy. Yeah, that's the thing. It's like on here, a lot of their images, when you scroll up, all of their pre-built ones are all a mega mega NZ download, and it's like I'm not downloading these. That's why I've built a lot of my own custom Linux installs on here because I just don't trust it. Even though I know it's a lab environment and there's nothing there, I still just don't like the idea of it. No, we don't want to partake in any surveys. Nope, don't want any of that. We just need standard and SSH. But at least if there's anyone watching and they've never done this before, at least they'll get to see it. That is the one good thing. It's like, this is how you install Debian. And this is the one that you get if you don't want to mess about with all of Ubuntu's add-ons, should we say. Put it on there. That one, next. Yep, snap, yep. Yeah, I don't like that. That's the thing. That's like before I used to quite like Ubuntu. Like when I was like, whenever I've played around with like Linux as a desktop, I used to quite like Ubuntu. And it's like, that's why I still put like my menu bar here on the left on my screen, because I used to like that style that you got with Ubuntu and GNOME. And then when they changed it, you know, I just didn't like it after that. Yeah, I just didn't like it after they started adding all that stuff. I prefer just to do apt install and have done with it. I don't even like looking for flat packs as well, to be honest. Right, so we've got that installed. Let's log in and update. So first is null 0 labs. Testing 1, 2, 3. Apt update. Apt upgrade. Issue do is not installed yet. So I need to SU up into root mode. Apt update. Apt upgrade. That's the thing. Once we do all the upgrade, once we update it all, and then once we do the rest of the steps, it changes the MAC addresses when you boot them up. But it should do, because I've never had any issues where it's set the same MAC address. But we can double check. All right, so everything's all good there. So let's apt install sudo, and then let's nano / etc doers. Null 0 labs. Okay, now let's do a reboot. What the hell? Why isn't that working? That's normally installed by default. What the hell's going on here? Testing 1, 2, 3. There we go. Right, so let's now get the basics installed, and then we will freeze it. So my list was to install this stuff by default so that we have it. If there's any more recommendations, let me know and we will put those in as well. Null 0 labs. Testing 1, 2, 3. So let's get my IP address. 68.134. I prefer this terminal. 192.168.68.134. At least now I can copy and paste. Ooh. Is that the way to go? Because like what's the difference between bird 2 and bird 3? How is there a reason why you would recommend that one over the other? Let's copy and paste those ones. iPad 3 as well, just in case. Nope. Trace routes there. Well, let's stick with this one for now. Okay, so we have bird, we have WireGuard. Okay. So that should be it. We're not going to mess about with the naming of it, and the interfaces will do that when we actually use them. So we should now be able to commit this now. So we've done the install, we've updated it. So now I need to commit it. So I can remove the CD-ROM from the location. So RM CD-ROM. And now I need to know where it is on the web interface. So I need to get it from the pod ID. So I'm looking for this. So I need EVNG, lab details. I need the ID. Now I need to go to cd/opt/unit lab/temp/0. That. And then whatever the node ID is, which is 1. And I'm looking for that file there. So what does it want me to do there? So once I get that, I need to commit it. Do I need to shut it down before I commit it? Because I don't want to have to do it again. Start the node, do the install like a normal Linux install, remove it. Do we shut, it doesn't say if we shut it down when we commit it. Although that is stopped. So I'm going to assume we shut it down. Because if we're going to commit it, I'm assuming we're going to shut it down. So let's stop it. So it's stopped. It's still there. Got the pod, we've done that. So now we are going to commit. So, yep. Image committed. So once we've done the steps above, we can make the image size smaller. So from the CLI, go to your Linux directory, okay, and then perform a sparsify. So go to the image directory, which was this one, -bird. Yep. And send it into a compressed version. Okay, let's let that run through. This is where it messes up and we have to do it all again. And it's pretty small, so I don't see it taking too much time. Whilst it's doing that, and then what's the next step? It'll take some time to compress, then we'll rename it from the compressed back to that. So I suppose what we should do first is probably rename the old one to .back and then change the compressed one. Or sod it, we'll live by the seat of our pants and we'll just do it as one thing. And then hopefully we can then drop an image in and start doing some of the setup. So we're going to set up a management interface. We'll use one interface that will connect to the other bird node via a router. I suppose we'll put a router in the middle and we'll do it all as IPv6. And then we'll create a WireGuard between them. And then we will configure the bird side. So we're going to do, we've done this. So this is the next steps after. That's still running through. How's everyone's Friday been? I hope you've not had too much of a awful day, seeing as the weekend is coming up. Nice. Mine starts on Wednesday, so I am I'm looking forward to it. Unfortunately, I still have to go into the office again on Monday and Tuesday, but I've got the weekend to start doing all the packing and getting all those bits and bobs done, and then yeah, Wednesday airport and sun lounger. Right, I'm going to I'm just going to go for it and see if that works. Okay, so we've got our image. So now we can now delete all of this. And we should now be able to even close this, and we will add a new lab bird test. And now we should be able to go node Linux, and we are going to want bird, and we're going to want 2 of them. And we're going to want 3 interfaces on each. B1, B2. And I think for simplicity, maybe we'll just do back to back to start with. So we will connect E1 to E1. We want a management network. 2 of them. And we'll connect those onto E0. And I suppose we will put behind each one a Linux desktop, just so that we can test reachability across once we get them up. So let's just say 2 clients. I can spell. I'll connect that onto E2 and E2. Right, so now let's start them up and see if we have any issues. See what the MAC addresses are doing as well. So third one, so null, 0 labs, testing, 1, 2, 3. Not this one. Null, 0 labs, testing, 1, 2, 3. So that's that one and that one. Let's have a quick shifty what we've got going on. MAC addresses are different, so that's good on there. Yep, MAC addresses are different. MAC addresses are different. Good. Okay, so we don't have to worry about that. So this one is 111 and 134. So I suppose we'll start with the one on the left first, and we'll do it in. Oh, hold on. I suppose. No, it didn't say I had to do that other command. Okay, so we're done with that. So we don't need that. We're done with that. So we want and currently we're done with this. So new terminal, we want to SSH into null 0 labs at 192.168.68. What was the left one? 134? I think the left one was 134. 134. Testing 1, 2, 3. So that one's there. Give me another terminal. Null 0 labs at 111. Okay, so we have our two nodes that we can access in a decent terminal rather than this VNC bollocks. So that's good. Right. So let's name them first so we actually know what we're looking at here. So we will set the one on the left. Node 1. Testing 1. Testing 1, 2, 3. Well, actually, nano/etc/local hosts, isn't it? We should call that, what was it, node 1. Otherwise, it will start complaining. We can test that. Right. Yep, we have node 1. Hosts. Node 2. Make sure that's committed. Yes, it is. Okay, so we can now identify our two nodes. Let me verify that. So now we're going to edit our interfaces. So we're going to use for our underlay a fake public IPv6 address, one on either side. And we will do the interface E2 on each one as a dummy interface that we are going to want to advertise across to each other. So the routed LAN side. So edit the network interfaces. Nano / etc / network / interfaces. See, that's the thing though. I do still think that this is a bit more of a faff compared to like the Linux boxes, the Cisco's, the Junipers and stuff like that of the world, having to jump in and out of different config files all the time, I suppose. But then again, I suppose it's what you are prepared to pay for, I suppose. It's like some of the stuff I've got on order for work at the moment, it's like 100 grand a router. So this one, which was, hold on, let's just double check that quickly. ENS3 is our management. ENS4, I'm going to take it, is going to be the underlay 1 and 5. Okay. So this one, just going to call that management. And then we're going to do IPv6 WAN. And we said this was ENS 4, wasn't it? Yeah, I'm sure we said it was ENS 4. iFace ENS 4. iNet annual, which means I take it that means we're not going to do any IP4 address. iFace ENS4 typo. iNet 6 static address is going to be 2001 DB8 on 100 1/64. And a LAN side, ENS5, I think it was. iFace ENS5 iNet static. And I suppose this would be what we're similar to the addressing that we use for the DN42. So we're just calling this 10.1.0.1/24. And then iFace ENS5 iNet 6 static address be FD00:1:1/64. So that should be our interface. System control network restart, is it? What is it under Debian to restart the networking? Or has it put it on there automatically? No, it hasn't. How do I bring that up? I could just restart it, but there should be a way to also just bring it up, I suppose. Let's have a quick Google. Debian 13 restart network. Restart networking. Okay. Should do system control. Restart networking service. Okay. That don't look happy. Okay, the address is there and it's up. And ENS5, the address is there. Yep. And yep. Okay. So let's do node 2. And I am not going to type that again this time. I'm going to copy it. And it was nano/etc/network/interfaces. It's not writable because I didn't sudo. No. So that's testing 1, 2, 3. Okay. And this side is .2, and this is a different subnet for each side as well. And this was ENS5. 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 What happened to ETH0, ETH1, ETH2, ENS4? 4. ENS4. I need to spend more time doing stuff in Linux, to be honest with you. I use a Mac all the time, but like my Linux stuff is a bit, yeah. So then sudo system control restart network ing, and then we'll see if we can ping. And then what's next? Create a WireGuard tunnel. So that means I should be able to ping the other side, which was, I have to do ping 6.2, wasn't it? And we've got a response. Good. Okay, so we've got basic network communication between these two interfaces. And obviously there's no default routes on any of these boxes at the moment. So the only way to advertise this network to this one is going to be with that BGP. And so we're going to have to use Bird to do that. So the next step, I suppose now, to simulate what we've been doing is to create this WireGuard tunnel over this now. So we've done that, we've verified, we can ping that, that's all good. So we now need to enable routing. Okay. Maybe I should have done that as a default file inside each node. So sudo nano/etc syscontrol 99-router.conf. And we're going to add IPv4, IPv6 forwarding. Okay. X. And then we're going to apply it. And then they both equal 1. Okay. And then we do the same on the other side. Yep. And then what was the command? sudo syscontrol -- system. Okay. We did that. We was able to ping across, so we know that that's working. Check routing. Okay. Okay, so I take it that's working as well. We'll check it over here. Yeah. Everything's happy. Right, generate WireGuard keys. So sudo make dir -p /etc/wireguard. Yep. And then, so then we're locking it down. Okay. I don't know what this umask does. I'm sure somebody can tell me. And then I take it we're going to generate some private keys, pipe it into a file, and we're going to do the same for a public key. And then I take it that is the public key. We can check that. Yes, so we have a public key and a private key. So now let's do the same on node 2. On node 2, create and lock down the WireGuard folder. And then generate the public private key. And then confirm /etc/WireGuard public key. Permission denied. So we have to use sudo. Good. And that matches. So that's this side's public key. That's this side's public key, which we're obviously going to have to share to each other so that we can make a tunnel. Never copy. Yep. Okay. So now we're going to create a WireGuard interface. And I suppose this is like how we did on the MikroTik. We created a WireGuard interface. Okay. So, although it was a lot quicker on the MikroTik. So WireGuard interface. Copy that. So we are interface address 100. We haven't used that anywhere, have we? No, but I was wondering if we could probably do the same as doing the, like, this is the same as doing like that. What was it? FE80::10. colon 10 colon 1 or something like that, /64. And then we want our private key and node 2's public key. And we're allowing their 2 LAN IPs, and then we're obviously going to allow their linked local address across there, isn't it? Okay. So let's identify that a bit better. Let's do that the same. We'll do was it FE80, wasn't it? Calm, we'll do this one as 20. No, they have to be the same, don't they? They no, they don't, because they come out of that slash thing, don't they? So that can go at that. Colon 1. No, colon /64. And that should be 10 colon 1. We'll try it. Okay. And then we need the other side's public key. I'm learning here as we go along. This is a learning experience, this one, that's for sure. Control X. Now, where do I get my public key from? A private key. And I take it we wouldn't want to broadcast this if it was live. So, yes, you do cat. So that's the private key. Now, if I edit that file again, I set my private key. So I've got my private key, the port I'm listening on, my linked local address, and then obviously I'm allowing their LAN IPv4 and IPv6 and their linked what's their linked local address. So take it I'm right. That is the linked local address. So I'm not imagining that, am I? What did we do for our linked local addresses? It was that, wasn't it? WireGuard. Yeah, like FE80 colon. Okay. And then obviously, yeah, it doesn't have to be the same on either side, does it? No, I'm looking at the wrong thing. This is what I want to see. No, that's not what I want to see. I want addresses. IPv6 address. Yeah, FE80. Yeah, okay, so FE80 was the link local. So we'll do the same, just so that we, yeah. So FE80 will do colon 10, colon 1 for this side, yada yada. Right, so now we need to do the other side's interface, which is that. And we need a similar config. And this side's address we said is going to be this. So this side would be at, say, FE80, and it can be colon 20, colon 1. We'll do the keys in a minute. And I'm going to allow that side, and the other side was FE80 colon 10 colon colon. And that was their public endpoint. Yeah, that was our public endpoint. Okay, now we just need keys. So this is our public key. Yep. And then we need nope. I need this side's public key. Yep. So I need that side's public key, and then I need my private key. So that was sudo cat /etc WireGuard. Is it in private key? Copy. If this comes up first go, I'm going to be amazed. Paste, Control X. Okay, so both sides have a WireGuard interface. And secure the file. Okay, always secure the file. Secure and secure. Next, we're going to start it. So start and enable on boot. So sudo as you do, and then enable it on boot. And enable it on boot. And now sudo WG. So that is transferring and receiving sudo WG. That is transferring and receiving. So I suppose I should now be able to ping the other side's linked local addresses. So I should be able to ping FE80 colon 10 colon 1. Morning, blah, blah. Oh, so I need to do percent. What was the interface called again? WG0. So yeah, okay. Okay, so that bit's the same then. Okay, so I'm going to do a ping again now. And I ping FE80 colon 20. What was it? I did for this side 20. It was colon 1. And percent WireGuard interface 0. Okay, so we've got both. So we've got an underlay, and we've got the WireGuard connection now between the two, and we're pinging the WireGuard interfaces between the two nodes. Sweet. To unlock your iPhone first. No, thank you, Siri. You'll need to unlock your iPhone first. So that's working. Okay, and then SUWG lets us see a similar output to what we see on that web interface when we have a look at some of the stats, doesn't it? So when we look at, say, something like, I think you do it on here. If we go here and have a look at load the WireGuard tunnel. So yeah, that's a similar output to what we are seeing here. Okay, cool. Cool. That's looking good so far. So we have secure communication now between our nodes. We can ping. So now on to the difficult bit. Let's get this bird stuff working. So what we're going to do here, we're going to take a backup of the config file. And then we're going to edit the config file. So left and right. So we're going to need to set a router ID. Now, I remember when I looked at this, okay. So my router ID on the left going to be 10.1.0.1. Why am I? So I'm going to enable some tables. But surely those are already in the system. What are these doing then? Protocol device. Scan time 10. Now, if we have a look at what works by default. So they got log, syslog all. They've got scan line 10 as well. And then import connect. Oh, so this is for importing connected routes. What is this? Does it say anything about the masters table? It doesn't tell you what that does. Okay. Protocol direct. So this is the same as bringing in and connected. So let's delete that out, because that is disabled by default. Okay. And then we're saying IPv4 tape. So is that saying that we're going to, hold on, right, I think so. If I copy this and put it in a minute, am I right in saying here that if we look at this here, it says that imports connected routes needed for next, is that then saying here that we are importing any routes from the static, any static routes from the table we may have, any static routes we may have in the 6 table, and any addressing from the interfaces? Is that what we're saying here? Because that's what I'm thinking. Because if it says here that that is imported connected routes, I'm thinking that's similar to when we select like re-advertise the statics and the connected interfaces. So obviously this one's going to be ENS 5 because we're going to want to advertise this interface's addressing. So we've done protocol direct, and then we've then got this kernel thing again. So protocol kernel, that's doing IPv4. So let's delete all of that. The kernel protocol is not a real routing protocol. Instead of communicating with other routers on the network, it performs synchronization of bird routing tables with the operating system kernel. One instance per table. So Bird's got its own set of routing tables then, and we're then having to synchronize them with the operating systems tables. That's how I'm reading that. So IPv4 table, we import and export everything from Bird into the kernel one. And then we're going to do the same for IPv6. And then I've got 1, 2 open. Scan time. I've got an extra one there, haven't I? So yeah, okay. So you got a bird table and a kernel and a operating system table. So protocol kernel again. So then this one is IPv6. So 2 open and a close. So tell master input over, scan and close. Okay, that says that's all that wants us to change. And their documentation. I suppose we'll come back to this later where we'll do some filtering. Let's just get stuff advertised first before we look at making it even more complicated. So let's do the other side, validate that it's working. And then I take it we're going to put a peer in. Okay. So router 2. If I save that, actually, can I validate that first? So let's validate that. Okay, no errors. Let's do this side. And we said our router ID for this side was going to be, let me bring that back up, it may help. So this side was 10.2.0.1. Cool. We enabled IP tables. scan time is 10. Protocol direct. So we're going to change that to be the same. And paste. And we're going to change the kernel one. Change the kernel one. Okay, so that, and then kernel 6. Kernel 6. Okay, Control X. And then we should be able to validate that. As you do bird dash p dash c slash etc slash bird.conf. No errors. So back to our notes. So we had no errors, no output. So now we should be able to restart it on both sides. And then check its status. So status, node 1, router ID, up and running. Copy. Node 2, router ID, up and running. And now check the protocols. So devices are showing up, kernel 1 and 2 are showing up, and static is showing up. Okay. What's this static one? What was that? I did see a section called something static. Static, so how come it's, oh, hold on, it's done static IPv4, but it hasn't done static 6. Should I put IPv6 there as well? So that it does both address families? But then technically we're gonna because you can put a black hole route. So I suppose you're going to want to put IPv6 there as well, aren't you? Let's just try IPv6 because we can't break anything. And then if we check it, oh, there's an error. Is that an error? Yes, it is an error. Okay, so we can't put that there. So is there a protocol static for v6? You can't tell me you only can put IPv4 static routes only. How do you do? Okay. We'll come back to that. Yep, no errors, so we can't do that then. So that is an error. Did it say anything in here about statics as well? Nope. What about their bird one? Did they say anything about statics? Statics route. See, I did IPv6. Yeah, so we want to reject our own. Not a problem. We will continue with progress, and you can always catch up with the video afterwards. It'll always be available in the live section. I'm going to come back to this because I'm thinking there should be, because I did IPv6 though, unless it's because I put it in capitals. Maybe it's case sensitive. Because I've got to assume. So I've got to create another one. And then do IPv6. So then I can then black hole a route for IPv6s. But when I do that under here, or could I do that on the kernel side or the operating system side? That passes the check. So if I restart it, and now if I check, there we go. So now we've got the two statics, and direct interfaces. Okay, so you're saying then, so under there, I could then go into that config file and say that IP block to the black hole, and then the BGP will be able to advertise it? Or have I still got to do it kernel side and then add it there? I'm just going to add that in on this side as well, just so that I've got them both the same. Seeing as we're doing both IPv4 and IPv6. So then I'll do protocol static IPv6, and then I'll close that. Check it, it passes. Restart it, and then show the protocol. So now we're matching. Okay. Bird C configure. Check. Yes, you do, I bet. Yeah, that's better. And then if I run configure, reconfigured. Okay. Cool. Perfect. So what have we got at the moment? So now we've basically got the equivalent of having Bird up and running. Okay, so that will call, so that's kind of like a, so this one's more like a kind of like the graceful way of doing it. If you do it that way, then yeah. So we verify this now. Verify bird routes. Okay. Okay, so let's pick that up directly from ENS3. So that's picked that. So let's pick that up then from ENS5, this one. Right there. And then I suppose if I do the same, but I do master 6, I should see the, yep, okay. And then over here, I should see 10.2. And 2 coming from ENS5 and 6. So now what? So if I was to say I wanted to, instead of doing this /64, say I had the 48, would I need to do a route at the operating system level to black hole, or would I go into that config file and under that protocol static section, would I put it there directly and then reload? In bird, okay. So you can do it in bird. So I would then and then here where it's got define my ASN. So if I was to, where's that? So we're going to use 65001 for the left and 65002 for the right. So if I was to come here and just go, that's my ASA, and I was to go 65001, and now if we copy this, this is what we're going to put on the left. So come in here and I'm going to come all the way down the bottom, and that says define my underscore ASN. So I take it that's a variable, and I should be able to use that instead. So here, if I was to say, if I was to just go like that, that subnet would then start being advertised across to the peer. Just like how I could do IP route black hole or IP route to null zero on the Cisco. So now come down the bottom. So what if I was to so where was that bit about ASN? So local AS, that's my ASN. And we set we call it my ASN. So local AS. So I should now be able to just go my underscore ASN. Okay. And the neighbor, we set the neighbor. So this is going to be the FE80 colon, we said 10, didn't we? Colon 1. No, so this is the neighbor. So we're going to go to 20. That's their AS. And we're going to source that from our FE80 colon 10 colon 1. And I take it I'm going to have to do that. Yeah. To say, because it's a link local. Yes. Okay. So similar to Cisco, yeah. So we have to do that. And I take it I'm going to have to do it from over here as well. For the neighbor. So I take it we'll have to go. Would we? So BGP neighbor percent WG0 extended next hop on, and obviously this is where we would put the filters, I take it, when we create them. Control X, and then you said we run SUD bird C configure check syntax error. What's page down on this damn thing? Ooh, root reflector. Ah, cool. That's what I want to maybe use this for, is maybe for a root reflector. So where was the error? Source address, percent. Yep. Neighbor. Then interface as blah blah. Yep. Source address. I've forgotten what it said in there. Was unexpected percent. What one does it not like? Unexpected percent. Is it in the source address? Oh, I think I saw this one before. It wanted source address, and then I think it wanted interface, didn't it? There was the yeah, and then it wants interface, and then the thing. Yeah, okay, yeah, I remember seeing this. So interface, WG0, and then that. Still an error. The next line down, syntax error. Oof, it's fun learning something new, isn't it? Yeah. Doesn't mean he wants me to do. Oh, for crying out loud. What is wrong with that? Come on, get down there quicker, man. Oh, does it want me to put it in quotes? I bet it's something stupid like that. So I use interface and then there's quotes. Maybe that's what it is. Source interface. Let's try WG0. Good. Right. So now if I just do configure, so that should now be set. So now if we come over to the other side, and we'll just take this config, come all the way down to the bottom of the file. I bet you can probably do this a lot quicker than me. Control Z, send background, back. Okay. Command V. Yeah, because that's the thing. I don't even have a page down button. Bloody Apple keyboard. So this side is that the neighbor is FE80 colon 10, we said, colon 1% WG 0. The source address is going to be FE80 colon 20 colon 1. And then the interface is going to be WG0 bracket. Extended next hop on. Control Z. Yes. So check. Configure. So I'm going to assume now so now we should see the node is established. Okay. Idle. No, it's not. Okay. This side was FE80 colon 10. Double check. FE80 colon 10. (65002) FE80. Neighbor is FE80. Colon 10 colon at WireGuard 0. Remote AS is 65001. The source address was FE80 colon 20 colon 1. WireGuard import export all. Control Z. I can to test that. I can ping that, so it should be able to reach that. Six five zero zero one. Nine 250. That's better. All right, so FE80. Yeah. Source address, FE80. Then next hop on. Just going to change that to 65001. Just in case. FE80 colon 20 is the neighbor. Colon 1. WireGuard 0. Should be able to reach it. Source address is FE80 colon 10. Interface WireGuard 0. Or do I have to put the percent on there as well? Now if I come over it, now that if I do I want to go line 250. I'm 65002. I'm going to 65001. Check. Figure. Still stuck in start. Oh. Why? FE80, colon 10, colon 1, WG0. Can ping it. And then I can ping it. So why are you not coming up? What am I missing? What am I missing? Is there a way to see a log? Oh, dog. Is there a, was it? General control, was it -U? Bird? Okay, that doesn't. Move the base man, okay. Nope, still stuck in start. Is there a bloody log file so I can actually see what's going on? No. So what is wrong with you? I'm sure it's just ignoring that, but I'll probably restart that. Okay. Why? I want to see more. Ten two zero one. Oh, XLR permission denied. Ugh. I don't know why we're stuck in start. We can reach each endpoint. Why can't I get more of a log as well? We are not getting it to come up. Can I log that out to, where am I? What's the home directory? It's that, isn't it? Nothing. No, we don't actually even need to do a TCP dump because we could just do capture E1. Oh yeah, I cleared my file, didn't I? That's why. Capture E1. Why are you not working? It's bloody WireGuard as well, so we won't see any of that. It's already got that. It's already on. Yeah, it is logging, but I'm not getting anything. When you check the it's bringing everything up apart from the nodes. So well, we have the neighbor. Not a problem. Extended next hop is on. IP6 within. Next one was on. We have that. We have reachability. We have reachability between the. So this side, 65001, neighbor FE80 colon 21 at WG0 or percent %WG0, source address, interface, local 65002, neighbor, WireGuard interface, source address. Yeah. Extended next hop is on. Then we try it. Let's restart the service. Restart the service. Let's check the status. started. We've got traffic coming through the WireGuard tunnel, so it's but it's not giving me any bloody log output. It's like there's got to be more than that. I want to see more than that. Okay. Is there a way of showing what happens when we try to connect? It's just stuck in start. The exact same. How do I get more of a log output? Google bird 2 BGP stuck start idle. How to see log. Yeah, that's not what I want to see. Protocol peer debug all. Okay, maybe we'll get some output then. You can see what's going on. So let's have a look at that. 250. Take it. I'm going to assume it doesn't matter where we put it. Waiting for it to become my neighbor. What are you doing? Maybe it's maybe I've done something wrong with the subnet on that. 250. Turn debugging on you as well. Debug all. And we will restart you. State change to start. Waiting. Suppose we could test it by not sending it through the WireGuard interface. I'm going to test it. What I'll do is we know that I'm going to just test it without sending it through the WireGuard tunnel first. That way we can actually see what's going on. So the neighbor is 2. This side we are .1. Let's comment out that. That's the wrong one. No 2. Uh, 250. Let's just see if there's some weirdness with WireGuard at play here first. So the neighbor is .1, we are .2, and we'll comment out the WireGuard interface. So then I should be able to save that, restart bird. Let's do the same over here. Where's that protocols? That was active and now it's reset by the peer. Okay, so there's something funky going on. That is 179, that is BGP. So it's obviously an issue with the WireGuard network then. Going over the Eve side of things. So this might be an Eve problem. neighbor 2, source address 1. Oh, typo, thank you. Neighbor 1, 2, Control X, yes. Restart. Just restart on both, just for good measure. Start active, established. So it's something when it's going through the WireGuard tunnel then. So where is this filter this BGP and yep, okay, so that's all working. So it's when it's going through the WireGuard. It's when it's going through the WireGuard that it becomes a problem. Nice. Hold on a minute. Let's should nano slash etc slash. I think I know. I think I know what it might be. Gauze. What is the subnet again for that? IPv6 FE80 prefix /10. Where are you? /10. Yeah. I should do nano /etc /WireGuard wg0.conf. And we said FE80 /10. And then if we true. But you never know. What was the MTU on that as well? Yeah, MTU is fine. I'm going to simplify it. It's going to be VA Concom 1 this side. /64x. This side, where are you? Just going to change the address on you as well, just so we can double check that I'm not being stupid. And you're going to be .2/64. I'm just going to reboot you quickly. And I'm going to reboot this one as well, just to be on the safe side. I'll reboot the whole thing. It might have been, but we was able to ping across. That's node 1. Yep. WG. So we're allowing that's wrong to start with. Okay, I think that's wrong. That's wrong as well, isn't it? Because that's FD 0:2, so I've messed up there as well. Okay, hold on. Testing 1, 2, 3. Testing 1, 2, 3. And there I'm allowing a 128. That's not right. So on this side as well, we should be allowing FD 00 colon. I should allow. Well, there's one quick way that we can test this. If we just go, we allow 0 to 0 to 0/0, and we allow, it's a colon 0, isn't it? And then we do colon /0. Control X under interface. How do you reboot that again? Is it down? Is it? How do I take it, bring it down and bring it up? Is it WG dash quick down? Otherwise it will create default routes. How do I bring the WireGuard tunnel up and down on Linux? Bounce. WG tunnel Linux. Up and down. Okay. And so we should be able to ping FE80 Concon 2% WG0. We can. This side, ping FE80 Concon 1 WG0. We can. So we've got reachability through the tunnel. And we know that the BGP side is working over the unencrypted tunnel. So now if we try and so now neighbor, yeah, I'm doing allow everything over the tunnel for now, just to so we can rule it out. So neighbor, we are doing. We said that was FE80 Concon 2 then WG0. AS is 65002. The source address is now FE80 Concon 1 for simples. And interface is WG0. I take it I don't have to do that because I'm specifying the interface, I assume. And you said bird, I can do bird C reconfigure or configure, wasn't it? Okay. And then now if I come over here and we do nano slash etc slash bird.conf. I don't know. I think we do because I think like on the even on like the MikroTik, we still have to specify that interface as well. And it did say when we was looking at this bit here that we need to specify the interface due to the linked local addresses that we're using. Then column 250. So this side we are AS 5002 going to 5001. This side it is FE80 Concon 1 WG0. Okay, I would. We're all learning on this one. I'm definitely learning when it comes to this editing in a configuration file and doing it this way. So FE80 Concon source address will be 2, and the interface would be WireGuard. Source interface will be WireGuard 0. Next hop is on. Control X. Yes. sudo bird C configure. Where's my... That's looking more like it. Let's ping a bit root print or IP root. So I take it up. There we go. So I take it that means I've learned it from Bird then. So now I should be able to go ping 10.1.0.1. Or have I got to source that? What was the IP address over here? It was 10.1.0.1. We are welcome. We are making a Bird routing server in ETH, and we are sharing routes via BGP. And I'm learning here how we build these. I'm more of a old school hardware networking type of person, so I'm figuring this out as we go along here with the help of chat. Let's try the IPv6 address. The 6 is working. I'm going to have to source it, aren't I? And the traffic is going via the WireGuard tunnel. So I bet that's ping, was it? It's -I, isn't it? Is it -I? 10. It's going to have to be sourced because the other interfaces won't know what to do with it. So it's 10.2.0.1, and I want to ping 10.1.0.1. Yeah, it's a source issue. So that's IPv4 and IPv6 working. Root print, no, IP root. Yep, and it's learned about. So don't forget the management interface has got a default root on it, probably. Yeah. So that's why I've got to source it from the interface. So if this side, if I do a ping and I source that from 10.1.0.1 and a 10.2.0.1, yeah, it's going across. And then if we do, actually do control -u bird. So there we go. So we can see that was obviously when I had that wrong port address. And then that's when we brought up the new one, connecting to there from local address, and it's got that. Yep. Sent the open, got the open, sent the keep alive BGP established. We then send our routes over. And we got ours back. So it looks like that's working now. What was that command again? Syscontrol. So let's have a look at the TCP dump. So I wonder as well now if we change the WireGuard and limit because this is going over ENS4. So if I do it on WG0, I should get the raw. No. Oh, actually, I should just not filter that. There we go. Now I can see everything that's going backwards and forwards. So if I stop that, and then if I restart the bird process, what else you do? System control, restart bird. It did yeah, that's all BGP coming over. And it re-established. So it's working. So should we check that WireGuard filter that we had in place? Maybe that's what was, because the config here, this was all correct on the first go. It's either that or it was a subnet, but then on the link local, we did a link local out of the FE80/10 prefix, so that should have been fine. So I think it may have been the filter. So let's test the filter first. But I think we've got the success we were looking for. We've got a machine there. I suppose the test that we can do is we can start up a machine on either side, give it an IPv4 and IPv6 address, and then see if we can ping full end-to-end, fully routed. That's what we should do next. And then we can then test the WireGuard filter theory, because I think that's maybe what it was, because we were doing where are you? Not that one. This was all correct. We were using similar addresses to what we were using on here. See, we were allowing that. But see here, actually, we was allowing that's allowing the larger block And then obviously you're allowing maybe I did mess up on the filter, the WireGuard filter. I think that's what it might have been. I think I messed up the WireGuard filter. Let's test that quickly. So we'll do, it was FE80 /10. And then we're going to allow, is it FD 00 /8. And then in reality, both of these are out of a 10. So we should allow 10.0.0.0 say /8. And then we can then get rid of this. So we're allowing the link local block. We're allowing the IPv6. Where are you? We're allowing the IPv6 block. And then we're then going to allow, because this one's a 24, the other side's a 24. If we just allow the 8, then we're allowing the full communication. So if we close that, and then it was sudo, is it WG, I've forgotten the command again, to bring it up and down, quick down, quick up. And then if we do the same over here, WireGuard / wg0.conf. And again, we want to allow FE80 /10. We want to allow FD00 /8. And then we want to allow 10.0.0.0 /8. And then we do sudo wg-quick down wg0, bring it back up, sudo wg, we ping FE80 /1 %wg1 at wg0, yes, so that's working. That is established. Let's restart that, hard restart that, just to make sure. System control, restart bird. We'll do the same on this side. System control. It's my STM control, restart bird. And then now if we check, so if I do SGDCN and I do show protocols, yeah, it's established. So I think I messed up the filter. And then if we double check that we can ping IPv4 and we source that from 10.2.0.1 to 10.1.0.1. We've got traffic flowing. Let's check the WireGuard. It's definitely going across. So it's working. Working. I use Linux Ubuntu with WSL2 in Windows 11 using Code AI. Code, I want to learn this. How do I do it? 90% of this thing is going above my head. Request to guide in newbie layman weeb code. You just do it. It's easy. Well, to be honest with you, this stuff, I'm also learning this stuff. That was the purpose of this live stream, to learn this bird system on Linux. If you ask me to do this with Cisco routers, Juniper routers, or the MikroTik, or Unify, or any other kind of hardware physical vendor device, then yeah, I can easily show you that, and there's many videos on the channel that can teach you some of those other things. But this bit is more somebody like Zippity's wheelhouse compared to mine, so I'm learning on this front as well. And I think if you watch the stream back, you'll see how from the beginning we've built these nodes from scratch, installed Linux on them, installed the bird routing software, and then created a secure tunnel between them, and then set up the BGP routing. So the final test, I suppose, is to get client 3 able to communicate with client 4, and then we know we've got a full routed path. So let's bring up this one. And show interfaces. That's the other one I would like to look at after this. Maybe when I come back off holidays, I'd like to look at this one. Why did you choose Bird over this one, this FRR? Because at least I saw this one, you have the ability to have a CLI. Now this looks more what I understand, whereas the other one is a bit is a lot different. There's a higher learning curve, whereas here I could probably install this, get into the CLI and start typing commands that are very similar to Cisco. So our address range is going to be that and that. Yeah, but it does have a configuration CLI component to it. That's why I was looking at it as going, oh, that one looks very similar to something I may be able to follow along with. Yeah, I'm sure I enabled it. We're going to find out if I did or I didn't. So this one was 10.10.10 to and going to 10.1.0.1. And this would be FD 00:1:10 64 FD 00:1:1 as the gateway. Apply. Ping FD 00:1:1. Okay, so we can ping that side. Bring up the right hand side. And give it an address. So IPv4 will be 10.2.0.10/24. Talking to 10.2.0.1. And the manual address was FD00:2 FD : memory like a sieve FD00:2:10/64 going to FD00:2:1 as the gateway. Show end-to-end test. Do we think it's going to work? Ping 10.1.0.10. Yay! It's alive. So client 4. This is client 3 for this side. And now let's send you back as ping FD00:2:10. There we go. We have IPv4 and IPv6 communication from the left to the right across 2 bird instances that we built from scratch across a sole IPv6 network with a WireGuard tunnel between them. I think we've done it. And it only took us, when was the time we start? 2 hours. I think that's not bad for a first go. Perfect. I suppose, yeah, we can do that. If it's installed on here, probably, yes, it is. Thank God for that. 10.1.0.10. So yeah, we should see it. Go to that address and then go straight to this address. Yeah, this is it. Go straight to the 10. So it's not going to see the in between. FD00:1:10. I don't think I've got traceroute 6 on here. Can I do a -6? Or do I need to put it in squares? Can I say it was again? D00:1:10. No. No. I need to update my desktop ones and put traceroute 6 on here as well. Use traceroute -6. No, invalid option. But yeah, I need to rebuild these desktops and reinstall some of the software on there. But I think that is a successful build, and I suppose now I will be able to continually just reuse these now the next step will be to figure out, where are you? Some filtering. At least we figured out how to put, so they're doing a export filter. That's pretty self-explanatory. Where did they put this filter? Yeah, I haven't got a version installed with that supports Traceroute 6. But like if I look at my toolbox, if I traceroute to what's one of my if I trace to, but when you trace, you will normally skip it. It will normally go straight to the other IP. I think when you do it with the IPv6, it will just jump straight to the next available IPv4 box, because that's what I've seen with the other ones. So filter, because we must be able to filter. That's the wrong one. Filters. No, I preferred the one where you just put the filter down on here. So where was that? That's what I was looking at. So where was this? Here we go. So define your own prefixes. Filter export. So did he apply that? Yeah, when you're going over the MPLS, you would normally turn off revealing your inner. So if I stop this, stop and stop. I close that and I bring up my one that I'm working on at work. So this is full MPLS SR core from front to back, NNI provider, bringing in customer venues via point-to-point Ethernet, and then handing off a service tag to me, and then I then look at that inner that outer S tag, and then take the inner tag and then send it off to the mobile phone operator or across to a network management system. But the inner core here, when you trace from the venue through the IPsec tunnel, because obviously these are, even though they're simulated here as routers, these are actually basebands. So these are the basebands that connect to send the mobile phone signal to your phone. And they will make a secure tunnel to this IPsec gateway here. And then when they make their tunnel to here, they are then passed across the MPLS core to the border router and then handed off to the corresponding network operator, where this border has a secure tunnel to the network operator. So when you trace route from here, even though you have all of this in the way, you'll see on the trace route that it doesn't reveal any of my core network to them. It just shows them the hop of their on-premise CPE, and then they will get the hop at the gateway, but they'll get their mobile phone operator's inner address, and then their next hop will literally be the mobile operator's core network that they'll see. But everything in here is all ISIS, segregated routing, MPLS core, so that we can then send off to the next pops from the core. These are the two secure gateways that handle all the inbound traffic, because all the basebands, even though they're connected directly via Ethernet, the basebands create their own encrypted tunnels back to the secure edge of my data center, because all the traffic in between has to be encrypted for Telephone Communication Security Act. So that baseband will make its tunnel to here. These are two Cisco 8500 series gateways capable of handling 400 gigabits per second of IPsec throughput. So, and there's two of those puppies that can fail over all the customers' traffic and then send it through our core network, which can handle here. Currently with this setup, this is 200 gigabit equal cost path, multipath, and then out as a 100 gig link to each operator, redundant. But as far as the trace route from this point to the operator's core or the operator's gateway, they only see hop 1, hop 2, hop 3, and that's it. And then into the core, even though they're traveling across a vast amount of equipment beforehand, because this is all layer 2 anyway. So even though these are technically routers, this is all layer 2. So these are all Ethernet flow points, and then basically customer traffic comes up, operator pushes on a service tag that's agreed by me. That service tag comes in here. I can then look at, say, service tag 1000 and 10,040, and then inside 10,040 there'll be the two tags for S1 and OAM. S1 is basically what we call your data on your mobile phone. So when you're browsing the internet or making a telephone call, that's called the S1 data, and then we encrypt that from the baseband to the operator. Yeah, but don't forget these are small cells, so there's not a lot to require. But like these, we can handle up to 400 gig in one location for those. So, and don't forget that's going to handle up to 400 venues. So that's not it's not about it's not about constant throughput. It's about being able to handle many. Yeah, as well. But the other thing as well is cost, dude. Cost. You're in this endless fighting battle against cost. So, but yeah, but these ones are. I wouldn't have even used those devices, but we had to use them again because of cost. So I couldn't go any higher than that. So, but like on this demo map here, we have them as Aristas, but these are Cisco in the real world. They're virtual, the virtual stacked core front and back, and then the borders in between. This is what we call our tier 1 F firewalls towards the customer site and the tier 1B security gateways towards the mobile phone operators. So yeah, so this is work, but yeah. And then this was where we bird test. So this is play. No, operators don't need to manage any of that. All we do is provide a path for the mobile phone operators to talk directly to those baseband devices. So because they're what they call small cell devices, so these are the type of mobile phone wireless devices that you would put in office buildings, very similar to say like a Wi-Fi point. So their throughput is lower, but obviously if you look at say a tower or what you'd find out in the street, you would have direct fiber from the operator running there. But because these are going into commercial locations, they're done over a IP core network. There's bits of automation, but again, a lot of it comes after the fact. The main configuration side, there's a lot of work involved to configure. It's like the tunnels can't be um, each baseband has to be manually configured out in the field and then fully tested before it goes in. So there's guys that have to sit there, test mobile phone service and coverage, test to make sure that the mobile phones disconnect from those small cells within the buildings and connect back to the macro out in the street, or one of those big antenna arrays that you may find up on high-rise buildings, etc. Those macro ones out there. There's a lot involved, so there's a lot of manual setup anyway as part of the deployment, and then the only configuration side within the core is just creating that tunnel for the handoff from the venue. So the main core side, once it's set up, it's a simple configuration of a tunnel interface. The rest is all manual configuration out on site. So yeah, so the front end side is all L2 Ethernet, and then it reaches the front door security gateways using Cisco's front door indoor VRF. So when the basebands create their connection back via the front door VRF, the transport VRF, they present their security certificate. Based on that security certificate, they're then placed into the VRF based on the mobile phone operator, and then passed to that mobile phone operator. So each mobile phone operator's traffic flow is kept completely segregated from each other. What I would like to just see now is where did I put you? Just want to make sure filters. So I take it you have to keep them separate. Can you combine those? eBay is trying to tempt me to buy more used networking equipment. We'll ignore that. Okay, so it's created one own 4, own 6. Where did it use that? So then, is that done under the peer? And you just export that under the peer, or is it higher up? Where was that peer configuration gone again? He's done that. Define your own prefixes, yeah. And then there's the peer, and it's done. Okay, so it's done under there. So I'm going to borrow your config there, mate. And then if, yeah, so that's similar to my rule on the MikroTik. So if it equals whatever, then accept it, else reject. Okay, so let's copy your thing there, and we will craft it to suit our needs, just so I can make sure I know what it's doing. We were in etc bird / bird.conf, wasn't it? And it was testing 1, 2, 3. Cool. I take it I can just put this in front. And I pop that there. And so we said we were on this side, we were 10.0.1.0/24. And we were only doing a 64. We were doing FD. FD00:1:/64 10.1.0.0/24 on this side. And then I take it we just come back down to here and we say, instead of that, I'm just going to do export that. And I'm obviously going to do export that, I think. And then you said I could do sudo bird c, and then it was configure check. Oh, got an error. Why did I fuck up now? Okay, where was the error? Was it line 250? Unexpected. Yeah. Export, filter. Oh, I'm missing the word filter. Export, filter. Oh, so instead of all, it's export, filter, and then the filter name. Okay. So nano. So still receiving that. So if we edit this one now, down to line 250. And we take that filter again. And on this side, it was 10200, so that's 24. And FD00 colon 2 colon /64. And then we said do export filter and export filter 6. Now, did you say if I wanted to advertise something other, if I was just under that static, if I black hold that, it shouldn't advertise it then, should it? If I put that there, is that the same as doing that and then putting a network statement in? IP route to dummy. Okay, it's using dummy. And it's advertising them. Okay, so you can put those in there as like that. Okay. But then I won't announce that because I'm okay. Try X. So let's see. Config check. Unexpected export. Oh god. Export. Export filter. Check. Configure. And then if I system control sudo journal control u bird. Should see that. Does it tell me that the filter is put on there? Where can I see, like on yours, Zippity, where you can see that output? How do I see an output like that with Bird? What I want to see is how do I see this output? I want to see more than that. How are you getting this at the session? Show bird BGP session. Ooh. Well, I did want it. Show protocols established, yeah. Show protocols all. And then that, okay. Show protocols all. And there's what, node 2? Ah, got it. Let's have a little bit of a comparison and see what we're seeing. And then we know that we've got something similar. Yep. That looks different though. Visual side filtered. Can you see more? Okay, show protocols all. Established neighbor address, neighbor AS, neighbor ID, local capabilities, IP multi-protocol. Next hop extended, done. Graceful restart. And there we go, that's what I'm looking for. And the filter is in place. And then obviously I take it I can do one for the internet and I can do the preference as well. Okay, cool. Cool, I'm happy with that. I'm happy with that. And then I take it I can do sudo protocols, show protocols, all node 1. Session is external. And yeah, export filter is in place for 4 and 6. Perfect. That's the basics. That is the basics covered. Cool. Cool, cool, cool. Let's just have a quick check to see how my AS is doing on here. Yeah, we're doing good. We are live. 3 neighbors, 2 of our pools advertised. Oh, we've moved up in the rankings. Nice. Cool. Let me check that my node is still up as well because I haven't bothered. Trace route to null0labs.dn42. Yep, that's all working. Cool. Sweet. I think, and considering how long that's taken, I'm going to leave it there. I'm happy with that. I think I've learned quite a bit about Bird tonight. I would like to probably take a little bit more time with it and have a look whilst I'm on holiday. I could probably sit there and read all about it from my sun lounger. And maybe have a look at using it, like I said, as a route reflector. Because at the moment, like you saw on that topology, the front security gateways here with the border gateways within the POP, and they act as the route reflectors for the 2 front security gateways. So those 2 are fully meshed, and then the security gateways pair with the route reflectors. And then what I was thinking was I could use a couple of these Linux boxes like this and have them operate as a set of route reflectors in each POP location. So you could put 2 low cost Linux devices in to act as the route reflectors for all the equipment within the POP location, rather than making one of those border gateways serve that purpose, because I don't want any BGP in the core. That's just all MPLS, ISIS, SR. So there's no BGP within that zone. So yeah, could try and put a couple of these in and have them operate as route reflectors, not doing what they're doing here. So yeah, so I think I'll take some time, read up over that. We reached all of our goals this week as well. In the I posted in the Discord, we hit over 1,200 subscribers now. We also managed to reached the point of getting channel partnership, which is good. So I'd like to thank everyone who's been following along with the channel's journey, and hopefully we can continue to grow and all learn from each other, and I can keep bringing something along to the table that you'll find interesting. There probably won't be a video next week, like I said, because I'll be away on holiday, sunning myself on a lounger, drinking vast quantities of local beer, and then I will be back after that. So I'm going to bid you all a good night. Thank you very much for watching. I hope you learned something, and I will see you next time.